Hello everyone and welcome to our video. Our topic for this presentation is data-driven approach to analyze the efficiency of LEED certified buildings in your Team 7. Building sector has presented a huge impact on environmental costs. It accounts for more than 1/3 of total energy consumption worldwide and nearly 40% of total GHG emissions. Based on those statistics, the role that buildings play in climate change is undeniable. LEED, by its holistic focus on efficiency and sustainability, promise to have significant energy and GHG savings. In our problem statement, we investigate, inspect, and predict the energy consumption for those projects to find out what are the actual savings.
Here are the objectives of our study. We will look at the correlation between LEED certification level and buildings' energy and atmosphere attributes. Then we will categorize LEED certified buildings in terms of energy consumption and GHG emission and compare them to non-LEED certified buildings with similar attributes. The impact of LEED score as an attribute to predict EUI for LEED certified buildings will then be analyzed. Next, we will use a supervised prediction model to predict the LEED score of non-LEED certified buildings by training a prediction model on LEED certified buildings. Finally, we will train a prediction model to predict EUI, which is trained on the New York buildings dataset, and we will investigate the impact of LEED score on the predictive performance.
Now, let's take a look at our two descriptive objectives. For the first objective, we will convert the categorical values of LEED certificates by assigning integer levels and use the descriptive statistical analysis to look for correlations between different energy and GHG attributes and the LEED certification levels. Both Pearson and Spearman correlation coefficients will be computed to investigate linear and non-linear correlations. The second objective finds the average energy consumption and GHG emission for both LEED and non-LEED buildings based on building types. We then compare the percentage energy and GHG saving of LEED and non-LEED buildings in the same building type. Now comes our three predictive objectives. In third objective, first to use regression methods to predict EUI of LEED buildings using all attributes except for the LEED score. Regression methods are selected as the target values are continuous. The goodness of the fit will be tested through cross-validation and the models are evaluated using RMS error. Same process is repeated, but this time including the LEED score. Finally, the error for both trained models are compared.
Our main objective in this research is to predict the LEED score of non-LEED certified buildings. In this regard, we separate labeled and unlabeled data based on the existing LEED score. Then we train regression models on the whole datasets and evaluate model through verification and validation methods like split validation. By knowing the best fitting model, it will be run on unlabeled dataset to predict the target, which is LEED score. And finally, we would be able to predict energy use intensity and analyze the relation between EUI and predicted LEED score. We train 4 models and compare 2 by 2 to achieve more accurate predictions. The first model will be trained on the labeled datasets, use the regression methods, and work with all attributes excluding LEED score. The target would be EUI. The second one is completely same as the previous, just LEED score, add 2 attributes to predict EUI. By knowing predicted EUI through the output of these models, we perform cross-validation and obtain the average EUI prediction error. 2 other models are the same previous, but we want to train them on the whole datasets including LEED and non-LEED data points and perform validation. In the end, we want to investigate the effect of the LEED score on predicting EUI by comparing the result of models.
The data warehouse built for this project contains data from 3 datasets. The first dataset is the US Green Buildings Council's LEED Building Directory. This dataset contains LEED buildings registered. The second main dataset used is the New York City Energy and Water Database from 2020. This dataset from New York City Open Data Portal contains the energy consumption per building and other attributes. Our last dataset is the USGBC LEED Building Score Breakdown dataset. This dataset was scraped off the USGBC's website for buildings in New York City. For the early data analysis, we prepared a few charts. This pie chart shows the LEED certification levels of the buildings in the data warehouse. This map shows the approximate location of the LEED certified buildings from the dataset. It was generated from their zip codes. This figure shows the points achieved by the LEED certified buildings. We noticed that some categories are neglected or harder to earn. Those 2 figures shows the EUI statistics of the buildings in the dataset.
This figure shows the statistics of the total greenhouse gas emissions in metric tons of carbon dioxide equivalent.
We will follow the cross-industry standard process for data mining methodology in this project. So far, we focused on business understanding and data understanding. Next, we will finalize data preparation by removing outliers and handling missing data. Once the data is ready, we will apply the models presented earlier to predict EUI and LEED scores. After that, we evaluate the models by looking at the accuracy achieved. Finally, Finally, we will then be able to comment on the efficacy of LEED certification in terms of energy consumption.